Hi all, today we'll see problem number 20 of Leetcode, that is valid parentheses. And let's read out the problem statement. So it says, given a string S containing just the characters, those brackets, okay, the round bracket, the curly brackets, and the square bracket. So determine if the input string is valid. And what's the definition of valid? So it says an input string is valid if an open brackets must be closed by the same type of brackets. So basically, if there is an open bracket which is of type round, it should be only closed by a round closing bracket. A round opening bracket cannot be closed by a curly bracket or a square bracket. This cannot be done. This is not accepted. Open brackets must be closed in the correct order. Okay, so if there is an open bracket, okay, it should be closed in a correct order. That means this opening bracket has the equivalent closing bracket that will be of this type, right? But assume there is a curly bracket, opening curly bracket in between these two, and this has the closing bracket here. Is it a valid string? No. Why? Because this is closed here and this is being closed here, and this does not form a valid parentheses. Okay, every closed bracket has a corresponding open bracket of the same type. So basically this 1 and 3 are a kind of vice versa, right? If there is an open bracket of the same type, it will be closed by the same type, and if there is a closing bracket of some type, it will have the equivalent opening bracket of the same type. Okay, so these two are pairs, these two are pairs, and these two are pairs, which is a valid parentheses. So let's see the examples. So this is a very clear-cut example where a round bracket is closed by a corresponding closing round bracket. Now coming to this example, this has a round bracket opening and closing round bracket, a valid pair. There is a square bracket opening when closing by the same square bracket, again a valid parenthesis, and again a curly bracket opened and closed by the same type, again a valid parenthesis. So this whole string is valid, right? Now the other example, the third example says a round bracket is being closed by square bracket, and that is not accepted, and that's why it is false, right? It is not a valid parentheses. Seeing the last example, in which we have the opening round bracket, opening square bracket, closing square bracket, and closing round bracket. Now what is that? So here, if you'll see, open square bracket is being closed by the equivalent closing bracket. Okay, so this is a valid pair. Okay, and talking of these two, this round brackets, okay, this round bracket is closed by the equivalent closing bracket, which is again a valid parenthesis, right? So if you'll notice, there is a pattern which we can see. How? Let's see an example, okay, which is this. So we are trying to use all the brackets, right? So this is a string given to you, S, and you have to find whether this is valid or invalid. So what if I'll say you if this is valid or not, right? This is string, this is valid, right? Because this round bracket is being closed by the equivalent closing bracket, and same this is true for this curly bracket, right? This opening curly bracket is being closed by the corresponding closing bracket, and same goes for this one. Okay, so let's increase the difficulty. So there is no string in between these two brackets, so let's add something in between. So what if I'll say this, and which we have already seen in the previous example, as this is being closed, right, and this is being closed in proper order and has the equivalent closing brackets. So this is a valid string, right? So let's say if there is an opening and closing bracket of the same type, right, this forms a good pair, if assuming there is nothing in between. But if there is something in between them, right? There is a middle segment consisting of a combination of different brackets, right? In that case, since this is perfect, this is valid, right? This opening and closing, assuming there is nothing in between. But in order to say this whole string is valid, I mean, we are assuming that there is something in between. In order to say that if this whole string is valid, we are dependent on the middle segment. If the middle segment is valid, we can say this whole string is valid. And if there is something wrong with the middle segment, if there is something erroneous in the middle segment, we'll say it is invalid, right? How? We have already seen in just the previous example that this, or let's change the example as this. So basically this is being closed, so this is valid, right? This is valid. And now since this forms a valid pair and the middle segment is also valid, so this whole segment is valid. What if this, what's for this? So this does not form pair, but this does, right? But since this is invalid, so this whole string becomes invalid, right? Clear? Now what if for what for this? So you say these two strings, these two brackets, there is nothing in between, right? There is nothing in between. These are two immediate strings, so this forms a good pair, and that's when it is valid. Let's paint with green. Okay, now these two forms a pair. Okay, so again this is valid. Now these two forms a pair, right? And there is something in between, out of which both of them are valid. So these two brackets have something in between, and the all middle segment is valid, so this is also valid, right? So these are valid, these are valid, this becomes valid since the middle segment is valid, so this is also valid, right? Now what for this one? This is immediate brackets, nothing in between, forms a good pair, has the equivalent closing bracket, it's a valid string, right? Now this is valid, this is valid, and we have this outer brackets. Okay, this forms a pair, has the equivalent closing bracket, and has all the middle segment valid. In this case, this whole string is valid, right? We can say this whole string is valid, right? Let's do one example. Okay, so I'll say there is an example of this. So let's write it here. This is, let's iterate it one by one. Okay, so this is a opening bracket. Okay, this is a opening bracket, this is a opening bracket. Okay, now this is a closing bracket. Now what is special about closing bracket? So special about closing bracket is, let's write it here. Okay, let's write the closing bracket. We are iterating from left to right. So you see these two brackets are equivalent, like they are pairs, right? This is valid opening and closing bracket, these are valid parentheses. So can't we say that if this is valid, we can simply forget this? Like we can assume between these curly brackets the existence of these two strings is valid, so we'll just ignore this, omit this. Okay, so okay, that is fine. The next string is curly bracket. Now you see these two are forming a pair, right? So opening and closing curly brackets makes a valid parenthesis. So again this is a valid, so we can just omit this. We can think that till here, till the fifth index, everything was valid. Everything as in the two pairs that we got was valid, because the fifth bracket is still in the memory. I mean, we'll see what kind of data structure we need to follow, but yeah. Then we'll have this next character, right? We have this round bracket. Next we have a closing round bracket. Again these two forms a pair, so then we can just forget it. Okay, and then we got the last ending square bracket, closing square bracket. again forming a pair. That is a valid string, valid parentheses, right? But if you'll notice, what we were doing is, I'll draw it again, but I hope this was clear to you, how we are evaluating, how we are omitting when we found the valid pairs, right? Okay, so I'll draw again, and let's this time we'll focus on what data structures we can follow, right? So we are at the first index, I mean 0th index, the first element, and that is a square bracket, opening square bracket. Okay, that is fine. Next we have this curly bracket, okay, in this first index. The next index we have a opening round bracket, and the next index we have a closing round bracket. But since this closing round bracket, okay, I'm not putting it, let's hypothetically assume that I have put it. So can you say this two forms a pair? So what I said, we will not put this, we'll just check if this is a closing, if this is a closing bracket, and if this element is being followed, okay, this is being preceded by equivalent opening bracket, that means we can just omit this and omit this. Okay, observe just one thing, that you are, this is the top element, right, as of now. Okay, so we'll delete this and let's draw the new here, I mean the remaining data over here, right? We'll see why I am doing this. So next we have this closing curly bracket. So again, we'll not draw a closing curly bracket. Instead, we'll see if the top, I mean currently we have the top element as this, right? So the top is opening curly bracket and the current index is the closing curly bracket. So basically we are seeing a pair, and that's when we'll remove this. So again, let's draw the memory that we have removed this, so only this bracket is left, right? Okay, now we are at this index, we'll have the opening bracket, round opening bracket, right? And we'll again follow go to the next index, that will be a closing bracket. We'll see the top element as the opening bracket, equivalent opening bracket, right? In that case, we'll just remove this one. Again, this is the top element, and we will be left with just a square bracket, opening square bracket, and the next index is closing square bracket. And that's when we'll say, okay, this is a closing square bracket, and the current top element, the top element is a open square bracket, and they both forms a pair. And that's when this can be removed, and the final stack, I mean the memory we are left with is blank, right? When you see the operation that we are doing on each iteration, if at all, even if we are adding to the right, that is basically the top element. Even if we are removing from the top, so you can easily guess the data structure that we can follow. So stack is something where we either put, or the push operation is which we do on the top of the data structure, on the top of the memory, and even if we want to remove the element, we remove from the top, right? So how in JavaScript we can implement the stack? So basically there is no dedicated data structure that is in JavaScript for stack. In fact, we have a very interesting data structure, that is array, which we can use to implement a stack. And we have push operation, pop operation, and at operation methods. Basically these are methods. So at methods which we can use to push, pop, and at can be used to peek element. What is peeking? So basically, if this is a stack and we want to just see, so we don't want either to push or pop, right? We just want to see the top elements. That is called as peeking, right? And that can be done using at method. What at method does is, at method takes the index, okay, and it can take the negative index as well. Like if you'll see 0, it will show you the 0th index element. But if you'll pass the negative index, for example -1, right? So -1, it will show you the last element. whatever there will be in the array, right? And that is equivalent to peaking, right? So let's try to code this, right? So what we are going to take, we are going to take a stack, okay, and that is just an array, because we'll use the methods of array to mimic the stack, right? And let's iterate over what indexes of what string, right? So we'll go to the length and let's say index plus. Now what we were doing is we were adding the elements to the stack when we were finding the opening brackets, right? So as soon as opening brackets are encountered, these are pushed into the stack. So let's say if is opening s index, basically the current index, current letter that we are encountering, if that is the opening bracket, so in that case let's push that into stack. So s of index, now don't confuse with is opening, there is no inbuilt method of is opening, we will be implementing that. And since this is just the one line inside the if block, so let's prettify it. Okay, let's define a method is opening, okay, and this will take a bracket, okay, and what it will do is it will just return the true or false value saying if it is a opening bracket or not. Okay, so in that case return if bracket equals, if this is the opening bracket, right, but there could be another opening bracket as curly bracket, or there could be another bracket that is square bracket, right, that is opening bracket. Again, since this is just one line, so we can get rid of this curly bracket and the return statement, right? So this is a method, don't get confused with it. So yeah, now if it was opening bracket, we were just pushing into the stack. Now what if it was not? So let's see, what if instead of this example, the example that starts with something like this. So you see, for this we are just checking if the stack's top element is the equivalent opening bracket, right? But in this case, this itself is the first element, so the stack is empty at the moment. So if we'll try to peek, right, using at method using -1 parameter, it will throw error. So in that case, let's make a check as if stack dot length equals 0. That means if the stack is empty and we are encountering the closing bracket, that means there is no equivalent opening bracket. And in this case, we should return what? False, right? Else, right? Else what should we do? Else, what if this bracket, I mean, this will be in the stack, this will be in the stack, right? And when we encounter this one, we'll see, okay, is the top element, okay, is the top element is the equivalent opening bracket of this closing bracket? If that's the case, return true, right? So we'll say if stack dot at what? -1. That means the last element of array, but we are mimicking the stack, so basically it's the top element of stack. So if the top element is get opening, I mean, if we are making a method where we'll just throw the closing bracket and it will give us the corresponding opening bracket. Okay, again, this is not the inbuilt method, we'll define in a while. So if that's the case, if the equivalent opening bracket matches with the top element, so then what we'll do is we'll simply remove, that is pop the element, right? And if that again does not matches, I mean, so basically what I'm saying is, what if this opening bracket is being closed by this? So this is not valid, right? in that case, the equivalent opening bracket of this square bracket would be this, but this and this does not matches. So in that case, will return false, right? So else return false, right? Okay. Again, to prettify it, let's remove the curly brackets since this is just a one line. Now, what next? So see, we are checking if is opening, then we are pushing into it, and if the stack length is 0, we are returning false. So now take this example, a valid example like this. So first, on the first index, I mean the 0th index, first element, stack this line number 8 will be executed and it will be pushed. Okay, it will be pushed into the stack. Now this is pushed into the stack, this is, let's say, stack, and this is pushed, right? Now going to the second index, first index, second element, the else block, it will go where? What do you think? So it says if stack length is equal to 0, stack length is not equal to 0, so it will go to this. So if stack at -1, basically the top element, that is opening bracket, is equal to get opening. Okay, get opening. So what is the equivalent opening for this? This one. These two are same, so this will be so what this will do is it will pop, right? So it will pop, stack becomes empty now, right? And there is no next element, so index will be exhausted, it will come out of the for loop. But you notice one thing, we haven't returned any result as such. So should we return true? Because if it will be out of this stack of out of this for loop, the guarantee that it will be a valid parenthesis will be true, right? If you're thinking true, that's actually wrong. So what if there is an example which says like this? Since all of them are opening brackets, so it will only go to the 8 number line every time for every index, and as soon as the index is exhausted, it will come out of the loop. And since you are returning true based on the false assumption, so it is not a valid result, right? In that case, you should write if stack dot length, okay, equals to 0, right? If that is empty, that means every opening was closed or being popped by the equivalent closing bracket, right? And that's when it will come out to 0. And how we are going to define this? One last method, right? Get opening, that is, let's have a okay, you can do anything. Let's have a get opening method which will take bracket, right? Remember to use a proper variable naming, because that is being checked indirectly by the interviewers, right? And don't try to save time by using b, if you think that renaming b would be much easier, which will save time, but that will hold a negative impression of you, right? So bracket, so let's use a switch case where we can say if bracket, okay, if bracket as, so what we are taking in get opening is a closing bracket. See, it is in the else block, and else block is only executed when it is a closing bracket. So it is a closing bracket. So if that is a closing bracket like this, we should be returning the opening bracket of it, right? And if that is a closing bracket of curly brackets, so we should be returning a opening curly bracket, right? And if lastly that is a closing angular bracket, we should be sending the opening square bracket, sorry, right? So this is it. We have defined get opening, we have defined is opening, and we have now fully written the is valid logic. So let's try to run this. Okay, all the sample test cases passed, so let's try to submit it. So yes, it is accepted. Now what is the time complexity that we haven't seen yet, right? So you see, so every time we are iterating any index, we are either doing a push or a pop, but these push or pop are O1 operation, right? And we are iterating every element just once. So at the worst, we are going till the last, right? We are not considering that we'll fail in the between, like we'll fail here itself. Okay, we'll fail here itself, that it does not has a equivalent opening bracket. We are considering that we'll go till the last, and that's how we basically calculate the worst time complexity. And since we are going till the last, so we are calculating all of the element, so its complexity will be O of so basically we have been provided you can see what code, we have been provided a string of S, so order of a string length, and that is the order of this algorithm. Okay, so yeah, that's it in this video, and see you in the next problem.